It's Mrs. Westmoreland, and I don't love the way Khan Academy explains limiting reactant stoichiometry, so I thought I would talk you through an example that actually comes from the Khan Academy practice test. So first, we need to know that it's a limiting reactant problem, and an easy way to tell that is what I've circled there in red. You'll be given two measurements or two numbers. So the next thing we have to do, which we always do in stoichiometry, is convert into moles, because the only way we can compare anything in a balanced chemical equation is in moles. And so we're going to use the molar mass, since these are grams, from the periodic table, and convert each one of the grams into moles. So since I have 24 grams of iron on the periodic table, the molar mass of iron is 55.85, and that's how many grams there are in 1 mole of iron. And so 24 grams of iron, when we divide 24 by 55.85, would be 0.430 if I round it to 3 significant figures. So 0.430 moles of iron. I also have to do the same thing for the oxygen. So I have 5 grams of oxygen. The molar mass of O2 is 32 grams, 2 times 16. So 32 grams per mole of oxygen, O2. So 5 divided by 32, and that gives me 0.156 moles of O2. So the next thing I'm going to do is something I call a mole to coefficient ratio. So we have to factor in the mole to mole ratio on the balanced chemical equation. And so one of the easiest ways I think to do this is just to take these numbers of moles and divide them by the number in the balanced equation. So I would divide the iron by 4 because of the 4 in front of the Fe, and I would divide the oxygen by 3 because of the 3 in front of the O2. So 0.430 divided by 4 is going to give me 0.108, and 0.156 divided by 3 is going to give me 0.052. So since this mole to coefficient ratio is the smaller of the two answers, that tells me that oxygen is my limiting reactant and that iron is my excess reactant. So I'm just marking them with L and E. So what that means is that I am going to use the oxygen to determine how many grams of Fe2O3 will be formed. And so it doesn't really matter where I start from. I could start from the grams of oxygen that was measured. I could start from the moles of oxygen that I calculated, or I could even use this mole to coefficient ratio and simply take that number and then multiply it by the coefficient of the Fe2O3 and then the molar mass. So if I want to know how many grams of Fe2O3, I would take the 0.052 that I got for the mole to coefficient ratio, then multiply it by the 2 coefficient of the iron oxide, and then I would multiply it by the molar mass of the iron oxide, taking the mass from the periodic table, 2 times the mass of iron plus 3 times the mass of oxygen, and I get 159.7 for the molar mass. So finally, I do that math, 0.052 times 2 times 159.7, and I get 16.6 grams of iron oxide as my answer. So my next slide is just sort of a summary of these steps. As just a reminder. So when there's two numbers in the problem, it's a limiting reactant problem. So you have to divide both of the given grams by the molar mass of each element or compound to get the moles. Then we need to factor in the mole ratio. So like I showed you, I'd like to divide the moles by the coefficient from the balanced chemical equation, giving me this mole to coefficient ratio, and the smaller mole to coefficient ratio is your limiting reactant. So now I've figured out how to choose my limiting reactant, and then I'm going to use the limiting reactant to find moles and grams of what is asked for in the problem. I hope this helps. Take care.